Hello everyone, welcome to Mathematics Step by Step. I am Ying. So today we'll learn the relationship between the area under a speed time graph and the distance traveled. Okay? So now we have learned about a distance time graph as shown in diagram 1 and also speed time graph as shown in diagram 2. Okay? So let us see the relationship between a distance time graph and a speed time graph. So let's refer to diagram 1 first. Distance traveled is s, then the time taken is t1. Okay, so the speed is v. The speed is the gradient of the graph. So when we come to a speed time graph, the gradient is showing the speed, okay, which is the gradient of a distance time graph. Okay, then time t1 is taken. Okay, so now we are going to do this mind stimulation one together. Okay, so part A is done. Let's do part B. A tour bus moves 150 km in 2 hours. Okay, so now we are going to draw a speed time graph. From the information given, we are going to get the speed. Okay, so the speed is distance over time, which is 150 km divided by 2 hours. Okay, so origin here, speed here in kilometer per hour, then time here in hours. Okay, so 75, 150 divided by 2 is 75. Okay, then here is 2. So the area under the graph is, we can see the area under the graph is here. Okay, it is a rectangle. So the area of a rectangle is length times width, okay, which is 2 hours times 75 km per hour. So the answer is 150 km. Okay, so the distance traveled is speed times time. Okay, 75 km per hour times 2 hours, so 150 km. Okay, then part C. Mrs. Malani cycles 8 km in 40 minutes. So the speed is in kilometer per hour, and then the time is in hours. Okay, I'll convert it into hours first so that it is easier when we calculate the area under the graph. Okay, so 40 minutes will be 2 over 3 hours, and the speed will be distance over time, so 8 km divided by 2 over 3 hours, which is 12 km per hour. Okay, so here is 12, then here will be 2 over 3. Okay, so the area under the graph is length times width, so 2 over 3 hours times 12 km per hour, so equals to 8 km. And the distance traveled is speed times time, so 12 km per hour times 2 over 3 hour, which is 8 km. Okay, we get the same answer. Let's check for part D. Mr. Gomez runs 4 km in 30 minutes. Okay, so 30 minutes is half hour and distance traveled is 4 km. So speed is 4 km divided by half hour, which is 8 km per hour. Okay, so speed here in kilometer per hour, then time in hours, so here is 8. Okay, then here is 1 over 2. Okay, so area is length times width. Okay, so half hour times 8 km per hour equals to 4 km. And then the distance traveled is speed times time, so 8 km per hour times half hour give us 4 km. Okay, so again we get the same answer. So what we can conclude from here is the area under the graph of a speed time graph is the distance traveled. Okay, so let's go through example 12 together. Calculate the distance traveled in each motion based on the following speed time graph. Okay, so we can see that the area under the graph is a trapezium. Okay, this part. Okay, so how do we calculate the area of a trapezium? Half times the two parallel sides, which is this part and this part. Okay, so 5 plus 10, then times here, so times 4 over 5. Okay, so we get the answer 6 kilometer. Okay, then part B, again the area under the graph is a trapezium. Okay, so I believe now you know how to calculate the area of a trapezium. Okay, half times this side is 80 kilometer per hour, then this side is 40 kilometer per hour, so 80 plus 40 is 120, then times here. Okay, but now here is in kilometer per hour, but here the x-axis is in minutes, so we are going to convert it into hours. Okay, so 6 minutes is 6 over 60 hours. Okay, so the answer that we get is 6 km. Okay, so this is a very common mistake that people will make. Okay, so you guys must remember, whenever the speed is kilometer per hour, we must make sure the time is in hours. Okay, so now let's go through example 13 together. The speed time graph shows the speed of Mrs. Liu's car for a period of 36 minutes. Okay, so you see here the y-axis is in kilometer per hour, the time is in minutes, so we must convert it into hour. Okay, so part A, calculate the total distance in kilometer traveled by Mrs. Liu's car for the period of 36 minutes. Okay, so total distance traveled. Now what we are going to do is we'll find the area under the graph. Okay, so now we will break into a few shapes first. The first is this triangle. Okay, so half times base times height. Base is 10 over 60. Okay, we must convert it to hour first, then height is 72. Okay, plus here we can see it is a trapezium. Okay, so half times both parallel sides, which is 72 plus 40, so 112, then this part is 10, so 10 over 60. Okay, we must convert to hour first, then lastly this part again is a trapezium, so half times two parallel sides, which is 40 plus 72, so 112, then time taken is 16 minutes, so 16 over 60. Okay, we must convert to hours, so the answer is 30.27 km. Okay, then part B, the average speed in kilometer per hour of Mrs. Liu's car for the period of 36 minutes. Okay, so now we know the total distance traveled, we know the total time taken is 36 minutes, so we are going to find the average speed. Okay, so 30.27 kilometer divided by 36 over 60. Okay, we convert to hours, so the answer is 50.45 kilometer per hour. So now again we have reached the homework. Go back, you guys will complete this self-practice 7.2b. Okay, so if you're struggling, you have a lot of difficulty in completing all this homework, I've prepared an online course for you guys. It is a step-by-step guideline in helping you guys to complete all the homework in this textbook. Okay, including the comprehensive practice at the back of each chapter. So coming next, we'll learn to interpret a speed time graph and describe the movement based on the graph. Okay, so do not forget to subscribe to my YouTube channel so that you do not miss out any of my upcoming videos, and I'll see you in the next video. Bye bye.